Let's go to the current status of Infinity and Beyond build. And later on, we can discuss blockchain for rovers. So let's discuss what I've been doing for the last 2 or 3 weeks. So in the previous status, which I presented, the assembly was something which you can see on the left-hand side. And now it looks something like something on the right-hand side. So I was able to assemble it last week. So last week was really productive for me. So I did a lot of things last week. But I learned a lot of things while assembling all these things, which we can go through later on. So the uh, suspension system is called triple bogie suspension system. It's based on the Rosalind Franklin rover, which is going to be sent next year. So there are three bogies, and we each connect to uh, axis on three sides of the rover. So like each rover has two wheels, or each bogie has two wheels, and then you connect them to the chassis, which is here shown in the center. So the Rosalind Franklin rover should seem something like this. I think this is a better one that shows its locomotion.
With our deployment actuators being strong enough, we can implement an additional locomotion mode, which we call wheel walking, which articulates a motion around this axis, and this motion gives very good traction capability in very soft soils and in very high slopes.
Eventually we will be able to go to places to find interesting elements on the surface of Mars, and basically.
Yeah, so the walking mode is not present in this one because you also need one more servo in this axle or axis. So this only has 2 degrees of motion per wheel. So the walking mode is not possible in this the rover I'm building. And the status of the electronics. So previously, I just had the servo hat and servos and Raspberry Pi, and I had to buy a lot of stuff. So I went on a shopping spree, and that is where I learned a lot while shopping. So I shopped around for some stuff, and which were like wrong stuff, and then I had to buy some other stuff again. So I got all the stuff and then assembled all the electronics. And then about the RISC-V, I pushed it to next year, so I won't be doing any more than like the hello world for RISC-V, and then I'll try to do more in the next year. But the base, so basically, can show what my tweet. So this is what I did for assembling. The first step was basically trying out the wheel control. So I just assembled one of the wheels and then connected it to the Raspberry Pi and the Raspberry Pi's servo hat. And then just tested a basic Python script, writing PWM values to the servo driver. And then this is how it looked. And then this requires some special, let's say, this power supply is I'm directly connecting here, but before it, there is a step down DC-DC buck converter. And this is how it looks. So what it does is like converts the high 12 to 18 volts and brings it down to 5 volts or 3 volts, which is required for the Raspberry Pi. So it's just a potentiometer based, and then there is an inductor and capacitor switching. It's basically a switching circuit. And then finally, the assembly should look like this. So the chassis has some internal, let's say, mechanical structures to assemble the Raspberry Pi. And then I what I did was I didn't shop for the DC-DC buck converter, which they had suggested from their shopping shop. So I bought all these from Amazon, and then this. So what happened was like these DC-DC buck converter has special screws which you can attach to, and then you can hold it, hold it down to the chassis. But now I bought a different one, and then the size was completely different. So that's why it is hanging here and there. And the software status, the previous state was I was able to teleoperate the rover in the gazebo simulator. So the same software actually runs on the current physical assembly of the robot. So I was able to test that too. And I was able to test the different steering modes. So this is the crabbing mode. So it moves like a crab. And then I also tested the Ekman steering mode.
Were these sample scripts that came with the ESA rover project, or did you write them?
No, these were all there in the software they provide. So the robotics lab of the European Space Agency, which released this rover, has all the software. So the software is running on the Raspberry Pi in a Docker container. And then, so there is a lot of setup going on. So I'll show you during the demo. So each wheel requires some neutral values of PWM for the steering servos and the driving servos. So you have to do some sort of initialization and configuration for the rover. So one of the mistakes I also made was while buying the servo is like, this is not the servo they suggested. So there is a servo in which you get a potentiometer in which you can adjust the PWM value with a potentiometer. So these are not those ones. So right now, when I turn it down, it slightly keeps on rotating with the small value. So I made a lot of shopping mistakes. I'll go through them one by one. And this is the on-the-spot turn. Yeah. And for beyond, the status is the same as before. So what I was able to do previously was I was able to teleoperate it with my Python SDK and scripts. So it's the same status. And for this year, I'm going to do only that. Maybe next year, I'll try to do more things with that. Yeah, so for me, the biggest lesson was like I learned the different kinds of standards and components that are existing, and then I bought a lot of wrong stuff, and then I had to buy them again. So the first one was the switching. So I didn't carefully look what kind of switches I'm buying. I looked at the component, and then just I bought a lot of stuff. And then when I was assembling the electronics, I realized that I needed a double pole single throw switch instead of a single pole single throw switch. And then I had to change the wiring a little bit. What they had according to the circuit, it's not the same which I have right now. And then I also bought. I did not buy the same batteries that they suggested. So its size is a little different. So for example, if you see this component is supposed to hold the battery inside. So it is made to a specific dimension, and now the battery doesn't match these dimensions. So this is basically useless. So my battery.
Why not buying what they said to buy?
Well, it was taking more time. Well, I wanted it faster. So they had a specific shop in which they had and it was also expensive, what they were suggesting. So I tried to buy cheaper, and then I had to spend a little bit more for, but I learned a lot about, otherwise I would not learn or have learned all these different things about different stuff. So for example, the RC batteries, I had to go through all the different connectors. So they also have different kinds of connectors. So initially I bought a battery with a EC5 connector, and then my charge, I had also bought a like lithium ion battery charger, but that does not have the EC5 connector. So then I had to buy EC5 to XT60 connector to connect it to the lithium ion battery charger. And then so right now my battery is connected with a double-sided tape, and the DC-DC buck converter is also like hanging inside the chassis with a double-sided tape, instead of having these mechanical assembly to put it down properly. And then I also learned about the screw standards. I never knew about these M3, M4, M5 standards. So I bought some of them, but like, for example, like I needed more of the M3 screws than the M4 ones, but they all come in a set. So I had like 10 of each of them, but I needed like 15 of M3 and then less of M4. So I had to buy the whole set again. And then when I bought the second time I bought, I went to a local shop, but they didn't have these button versions of. So there are also different kinds of M3, M4. There are like button ones, and then there are these wedge shaped. And then like, depending on the screwdriver you want to use, you can have this star shaped and or the Allen key ones, or the, so like there are lots of, so I learned a lot about different screw standards and where to get them in like Finland and the shops which sell them. And then the other thing I bought was the servo extension cables. So what you, so the cables are not very long enough to come to the servo driver from the wheels to the servo motor driver. So I bought a really long one. So all of them are like really long ones. So I have like maybe 25 centimeters of extra cable inside. So if you see all my videos, the hat or the cap of the chassis does not fit on, like does not go inside, because there is a lot of cabling inside. Yeah, and this I already mentioned. So the battery was a different size, and so some of the internal mechanical components, well, they are not of use anymore. So a lot of things learned about, like where to buy stuff and where to look. And
So this is interesting. We ran into a lot of the same issues, even though I was doing my own design. I had the XT60 problem because the battery and the cable extension thing. I also had the extension wire problem. So I think part of it is just I don't know, random sourcing. But I'm surprised you couldn't find like a proper hardware supply store that'll allow you to buy like just M3s of a certain length. Like in the US, there's an online store, McMaster Car, where it's like really amazing. You can like order almost anything in precisely the size and head shape and everything you want. So initially I did what you did, which was buy an assorted M3 box. And then I realized I need a specific amounts of M3s and M6s. So I bought just the type I needed from McMaster Car. So I'm sure maybe in Finland it's too small to have it, but I suspect there's something like McMaster Car somewhere in the EU that delivers to Finland, right?
yes, so there are shops here, but a lot of them are in Helsinki. So the city I live in is like, so if you are like a industrial like company or something, then you have a lots of sourcing abilities because you are buying a lot of them. And then these RC batteries also, I had to buy it online from Helsinki. And like the local electronic shop here, like doesn't have many of the RC components. So, and the companies here buy directly from the suppliers. So the retail shops doesn't have many options here in Oulu. So Helsinki definitely will have many of them. So, but Oulu is a really small city.
So for a future session, it might actually be interesting to compare and contrast our different shopping experiences in different countries. Like right here, we have Japan, Israel, EU, and the US represented. And I think shopping alone will teach us a lot, just comparing the experiences. Anyway, yeah, that might be an interesting session.
So most of the things I bought it from Amazon, and like but Amazon only has like sets of these things. So they have like standard sets and then you buy them. So I have lots of extra components. Maybe I'll build some other small robots. Let's see what I do with the extra components. Yeah, and so for the next steps, so I want to clean up the assembly. So right now it's kind of a mess. Half of the parts are hanging here and there, and then half of the parts don't fit. And I haven't assembled all the things. So the camera I haven't assembled to the rover, and then the head assembly and the fake solar panels. I'll do that next year. So they are like cosmetic things, except the camera. And the outer wheel is needed if I am planning to take it outside. I don't think this is like right now the wheels I have, like they don't maybe not work well like in the outer environments.
When are you
And
going to uh, do your first drive?
yeah, it's actually, I can already do it. I just have to charge the battery and that's it. Right now I'm powering it with the DC supply. So it's sitting on my desk. I have a demo ready actually. I can share it after the presentation. And yeah, electronics also, it requires cleaning up of the wires, and I have to maybe, so I have bought a Oak D Light depth camera, which I'm planning to attach, but that will arrive in December. So that will be also pushed to next year. And software is completely open-ended for me right now, so I can do a lot of stuff. So basically I have the basic mechanics and electronics ready to drive it around. So I'll keep adding things and maybe take things from the other like other builds and try to integrate it with here. And yeah, beyond right now, it's also just teleoperation. And then I plan to integrate it with the rover itself. Right now, it connects to a different wireless access point. So I want to integrate it with the same wireless access point or connect it directly to the Raspberry Pi. And then maybe this also is like a stretch goal will be pushed to next year, add the ESP-I to the drone. Yeah. Maybe I can show the demo and then we can have a question session. Mm. Something is not properly done, right?
Do you? Okay,
Yeah.
yeah, now it's clear.
It's clear.
Okay. So it's not possible to share the camera or is it? Yeah. And then so you cannot have this at the same time or what? Like share my screen and then also my video.
You need something like OBS
Okay.
thing for that. I think here you can only share one thing. So
Okay.
No, wait, you can share multiple windows. So if you stream your camera to your screen, you can show side by side, both one and the other.
Okay. That will require some setup, I think. Or well, let's see the demo itself, and then I can show you separately what I'm doing on the Raspberry Pi. So it's right now booting up the Raspberry Pi.
This needs more flashing LEDs.
Yeah, I could attach the LEDs. I have some extra stuff lying around.
Also, googly eyes.
Yeah, so
Yeah, the LEDs could go into the eyes actually.
the thing that Eric is putting together has special LEDs that are controlled by a single pin of the GPIO that allow you to do all sorts of flashing and streaming and other visual effects.
When I see the wheels rotating
Yeah, so
in opposite
that is because
directions.
it's I don't have this the servos in which you can like adjust the potentiometer to make it stop. So this is supposed to be the neutral position. So so I have bought a lot of wrong stuff.
Okay, so it's got some zero drift problems.
Yeah.
This seems like it would be a common problem, and there should be like a hack around it. Like, I don't know, ground it to something or something like that.
Yeah, I haven't searched for it yet, but yeah, it should be possible.
Oh wait, I forgot. You're doing actual servos rather than DC motors for the drive wheels as well, right? Which
Yes.
means you're sending like a particular frequency, 90 hertz or
Yeah.
something. Okay, that's why
So
this is
like you can adjust so it generates what the software they have done is like there is a configuration Python configuration script which like by adjusting the potentiometer and then it records the PWM and then stores it into a YAML file. So I can try different PWM values in that YAML file and then actually I can adjust it, and I've done it. So like I might need to make some modification to that YAML file, and then I might be able to figure out how to have a neutral like non-rotating position.
I have a similar version of this problem on my steering servos. My main drive motors are DC motors, but my steering thing is like 180-degree half circle servos. Yours are full 360 degrees, mine are 180. But the problem is that when you send it to the zero position, the steering alignment is way off. Like I thought I had done the alignment properly so that all the like arms were properly set up, but they're not. Like the actual electronic zero position is not the same as the mechanical zero position. So if I send zero to all the steering motors, the wheels are pointing in all sorts of different ways. So I'm now thinking whether I should fix the problem mechanically, as in like detach the wheels and reset them to be so that mechanical zero equal to electrical zero, or should I compensate electrically and do an offset, like, zero is really minus 24 degrees or something like that. So that's kind of an interesting problem in general for these 0-point calibration aspects of mechanical to electrical.
Yeah, so there is, I had to do some calibration. So the position of the steering wheel, which you are seeing right now, so I had to adjust it so that the 90-degree is pointing towards the front. And when I attach the wheel, so that it can turn like plus 90 and minus 90. So in like right now you are seeing the wheel as straight, so it can like go plus 90 and minus 90. So I had to attach the, I don't know, the flanges in such a way that it's possible, and attach the wheels also similarly.
Yeah, same problem with me. So I haven't yet done that because it's like annoying mechanical disassembly and reassembly.
Yeah.
That's why I was thinking of, is there a way to like digitally compensate? But of course, then you give up the range thing. Like if you set minus 24 degree equal to the new zero, then you won't get plus minus 90. You'll like give up some range on the rotation. But it's kind of an interesting question. Like, can you compensate, especially like if you talk about scavenging, like you're already kind of doing de facto scavenging by like substituting parts for other parts. So in a way, this is what would happen if like rovers were scavenging each other. And then you would have to ask, all right, if a rover is trying to like, I don't know, steal a motor from another rover and attach it, and then can it actually have the mechanical capacity to recalibrate its positions, or will it have to compensate by software? So interesting bunny trail there.
Yeah. So right now let's try the grabbing. So I have a, let's say I'm connecting it to the rover via browser. So they have made a browser-based interface, which I will show after the demo or when I am like done doing this. So they have like a few buttons for the steering, and then there is also a camera streaming, which is not working right now. And then this is the Ackermann steering. And then this is for turning on the spot.
What was the previous steering? I mean, I just saw the front.
It's
What
called
is special to it?
it's called Ackermann steering. Like I don't know the exact details, but I know this kind of steering is called the Ackermann steering. So mechanical things I don't know about it.
So the Ackermann steering is basically when you're doing a standard curve around a corner, the outer wheels need a longer radius of curvature than the inner wheels. So they kind of have to be set at different angles. So the Ackermann steering formula basically gives you that different rotation angles for inner and outer wheels. That's
Okay.
basically
All
all
right.
it is. Yeah.
Thank you.
That's why I was wondering like why they are all different at different angles. Okay. Yeah. Okay, I'll stop this stream and then show you how I'm controlling it. So this is the interface on the left-hand side. Is my screen visible right now?
Yep.
Maybe this is better. So this is the Raspberry Pi VNC viewer, and then this is so there is some nodes running which are taking like waiting for commands on this port, and when I'm connecting to this port, and then I start grabbing, so it will set the locomotion to grabbing mode, and then this is kind of a joystick. For moving the motors, and then for spot turn, this is the mode. And then for Ackermann. Yeah. And this is for stopping the motors. The center part is for the camera. So when I attach the camera, the stream will be streamed in the center of the this interface. And it's also possible to connect a joystick. I have a joystick lying around. I'll be connecting it to the rover later on when I am taking it outside. Yeah, so this is the status, and then so this is all running inside a Docker container. So they have provided some scripts. So this is the config mode that will build right now everything is built, and then for example, this is the script they have for setting up. So the drive motors a neutral position, and then it stores the config file to this XMI YAML file. And then so for they have done it nicely, the scripting. So it's easy for a beginner to just use these scripts and set it up everything. So it was quite convenient to do all this. And then yeah, this is how the config looks like. So when you open up the steering configuration file, it asks you like which pin of the servo motor driver is the actual servo connected. So it will move, send some PWM to each pin, and then you can check which motors are moving, and then it will generate this steering wheel pins, and then it will ask you to add like find a neutral position, like so that each of the wheels are straight, and then it will set the PWM for the straight or the neutral position for the steering wheel. And then similarly for the driving wheel to like, so that it's not rotating. I could adjust these values and see which, if the drive motors are rotating or not. So what I'm planning to do is like have a neutral. So this value doesn't make all the wheels stop, because then I need the potentiometer. So what I might do is like have a separate PWM neutral value for each of the drive motors. Yeah. And for starting, so this is what I do for starting the software. So it builds everything with ROS, and then starts up the server, which I can connect to with a browser. Yeah, so that was it. Maybe do we have time? We can quickly go through some questions.
Why is the software in a Docker container? Any particular reason?
Well, I think they did it so that people could use different kinds of Raspberry Pis. So I can use a Raspberry Pi 4, Raspberry Pi 3, and they are all different architectures. So a Docker container runs on both of them. And right now I'm using a Raspberry Pi 3B Plus, but I also have a Raspberry Pi 4 lying around. So let's see which one I use finally. But this has been working, so.
And what's the power management like? How is the battery power managed? Is there like a separate breakout board or something?
Power management for what?
The battery, like if it runs on a battery, checking power levels, regulating it, recharging it.
So yeah, so I have a, let me show you the charger. So RC battery charging is itself, you need to learn a few things. So this is the charger I have. You can see.
Yep.
So it cost me around like 80 or 90 euros. So this is like a mid-size or like a mid-range one. So you can, I think the range was from $50 to $150. So I got this for around 80 or 90 euros. And it can charge nickel, cadmium, lithium polymer, lithium ion, different kinds of batteries. And then while discharging, you need to attach this alarm. So these are lithium ion battery alarms. So I have to attach it, and when it goes below a certain value, it will start beeping, because when lithium ion batteries are charged and if they discharge below a certain value, you won't be able to recharge it.
And this will be on board, like when it's untethered from the charging cable. Okay, so it'll start, your robot will basically start beeping if the power is too low. That's the solution.
Yeah. Okay. So you have to buy the battery which has like, you can connect these beepers to it. Okay. So, and you can, so these chargers also come with these, I don't know what these are called, but you can attach the same connector to this, and then it like monitors how the lithium ion battery is being charged. So that itself is like its own rabbit hole, because the RC car industry, like the toy, so it's a really big thing. And then you can buy lots of different kinds of lithium ion batteries. So I have a 3S, and then for charging also, like you can have like different ratings, 55C, 45C. At what rate are you charging or discharging the lithium ion batteries? For example, some of the the lithium ion batteries which are RC cars are using, they require like high discharge rate. So for that, it's a different kind of RC battery. So that requires like some digging around to find what your requirements are, and then what you are supposed to buy. So I bought like something, the lithium-ion battery, which was similar in rating to what they suggested. And the power management is, so from the batteries goes to the DC-DC buck converter, and then it brings down the voltage, I think for 5 volts for the Raspberry Pi, or like for the servo motor controller, and 3 volts for the Raspberry Pi or something.
You mentioned that you had a lot of cabling inside the body of the animal. How does it look right now?
Let me show you how it looks.
Ah, wow.
So there's a lot of extra cabling. I didn't want to, I could have cut it, but then like it is a hassle to like recable the small and crimp it. I don't have a crimper, so I might just buy a shorter cable.
No, it's still work in progress anyway, so better to cut later, right?
Yeah, I can actually drive around with this setup. I just have to tie these cables, which are like close to the wheel, with a zip tie, and then I am able to drive it around. I've not tried it yet, but maybe next week I'll try it.
Okay. And is it warm inside, or is it just fine?
No.
Because right now in the body you have the cabling and the compute as well, all in the same box,
Yes.
right?
Yeah.
But
So,
because it's a Raspberry Pi.
I have a
is usually
heatsink.
between 50 and...
I have a heatsink on the Raspberry Pi. That's the only heating like measurement I've taken for like dissipating the heat.
Okay.
And I
we can
haven't
see also
faced any problems yet, because I've not been driving it around properly.
Yeah. We can you just showed the picture, and we saw that on the picture I could see on the right the middle wheel is still turning. So I guess it's what you were talking about with and Venkat has a similar issue. It's still turning, right? Yeah.
So it's a servo motor for the drive wheels too. So it's sending a PWM for the motors to drive. So I can stop it by setting 0 PWM to it. But there is a neutral position in which it remains still. And the actual shopping list had a servo in which you have a potentiometer which you can adjust the PWM, and then it actually stops. But right now I don't have those servos, so I bought the wrong servos.
Yeah. So you mentioned it's because you chose different components.
Yes. So they have a shop in Netherlands. I think it's close by to the lab. It's the ESA lab is in Netherlands, and they had a online shopping like suggested shop, which like they had bought it and they suggested that to buy, but it was like the lead times were really long. And then I wanted it faster, so I went to Amazon and looked at similar components and bought everything quickly. And then I realized half of the components are not the ones I bought.
And I guess also that component from the Netherlands was also pretty expensive then.
A little expensive than what I got from Amazon.
One question then is, in a motor, usually in engineering, it's on or off, basically. Okay, we can control that perfectly. Okay, but here we can see that there is basically it's more analog. Okay, and it's like it's alive basically. Okay, if we take our limbs, okay, our biological limbs, they are never completely at rest, right? There is always something happening. And I wonder whether it's something that can be exploited in the sense that there is signal, okay? And this is a data stream. And I wonder if there is something that can be done out of that. Yeah.
So like if I set the PWM to 0, it stops rotating. So it's just not like tuned properly right now. So I think it should be stopped right now. Yeah, it's not moving right. Yeah.
And sorry, that's where I wanted to go. Sorry, I forgot.
Yeah.
Is this something? Venkat mentioned about hardware or software compensation or tuning or calibration. I don't know. I wonder whether they, it's not something that could be done here. Is without using a hardware potentiometer, is to have a small software, getting some data, and based on this data, automatically setting the YAML file you mentioned.
Yeah. So for example, let's go to the YAML file.
I mentioned that because it's a big problem for self-driving cars. The calibration of their cameras and lidar and
Yeah.
so on. And
So this,
yeah.
so this is the PWM that is supposed to stop it, and then what I'm supposed to do is like adjust the potentiometer so all the motors are not moving. But since I don't have that special servo, what I can do is like have add some, like for each drive motor, I can add a separate PWM, and then like change the software so that it takes the PWM mentioned separately for each drive. So that is like a quick software fix.
Okay. And have you tried a little bit already to do that?
No, it was like
Okay.
I'm testing it on my desk, so I haven't tried too much.
Okay. I'm curious whether it works well or well enough, I would say.
Yeah, it like works well enough to drive around in my room, I think.
Oh, so sorry, the calibration, I meant.
Okay.
To find the 0 point by software only.
Yeah.
Hmm.
Any
Thank you.
more comments?
Do you have, when the wheel is not moving, it doesn't draw any current?
It's like the motors are always like having some PWM, so it's drawing some current. Yes.
And you can't tell the motors to go in the unload mode?
Yeah, I can do that. So there is a script for it. So what it does is like set the PWMs to 0, and then the motors are not drawing any current.
But if you want it to be locked at 0, then you have to have a number.
Yes. If you want to stall it, then you need to have a number or a PWM value.
Okay, but that really uses up the battery, I assume.
Yes. So if you are climbing like a slope or an inclined plane, and then like if you let it go to like a freewheeling state, it might roll back down.
Unless
So you need, yeah.
turn
So
the
if you,
wheels, so it
so
displays the
yeah, so
wheels
if it's a like a sandy surface, the inclined, then it might stay there, because I think these wheels have some like sharp pointed stuff coming out, so it will stay there, and it's heavy enough. It's not that light. It's like you can feel it's like I think more than 2 kilos.
2 kilos.
Is your motor, when it's when it's drawing 0 current, is that a freewheel state or a locked state? Because I think there are most motors are locked when they don't draw current. You have to like pay extra to get the special ones that can freewheel with 0 current.
No, so if I set the PWM to 0, then it's like freewheeling. But you need this like PWM so that it's not it's like stays at the current position.
So that's actually surprising to me. So by freewheeling, you mean all the power is off, and if you try to move the wheel by hand, it's easy to do that, like no resistance?
Yeah. Yeah.
That's, I'm curious about your motor now, because all the motors I've tried, when there's no power, it's actually hard to move it. So I've actually been wondering about the opposite problem, which is how do I force my motor into a freewheel state? And that's actually not trivial. Like you either need a clutch mechanism that's a mechanical solution, or you need sort of a magnetic compensation that allows it to freewheel. So it's funny that
freewheel in the sense of like freewheel for a servo, not a freewheel for like a DC motor, which will rotate freely. Like freewheel, like yeah, you will feel it. There is like some torque when you try to rotate it, the wheel.
Okay.
So
what I mean is, if you put it on a slope, is your thing likely to roll down? Because mine won't. It'll just stay there, and it'll be static friction. It won't be rolling friction.
I think it
So-
will depend on the friction provided by the inclined plane for this, because it's already like 2 kilos. And if it's like, if the friction is not there on the plane itself, then it might roll down. But there is some like torque when it's in the when there is no current, so it might stay. So it's difficult to say. Yeah, but like by freely wheeling, I didn't mean that it will rotate like once you give it a push, then it will keep rotating. No, it won't.
One of the things that I have in the leg robot is that if you unload the motors, usually the rover will not collapse, but if you touch it, it will collapse. But I think what's more interesting, you can't do it because you don't have sensors, is that you can move the motors to the position you want the rover to learn. So for example, if you're talking about crabbing movement, or I talked about a locking position where your wheels go like that, and then you can't slide down. So you can teach your rover to do that if your rover can detect this angle.
Okay, yeah. So I haven't played too much with the software side at all here. So I'm just trying to run whatever standard software they had. On top of that, I could add different things next year.
No, you need some sort of feedback. You're saying you don't have any feedback at all.
Right now, no. But I could buy the motors. So
I don't think
And-
you mentioned this, but what is the motor controller for this? Like, it's not plugging directly into the Raspberry
it's
Pi.
called PCA 9685 or something.
And this is a hat with 4 motor or 8 motor
a
outputs
six-
or whatever you need.
Yeah, it's a 16 channel 12-bit PWM Raspberry Pi hat. It's a standard like servo motor driver controller.
Okay.
It's actually like the data sheet actually says it's for driving LEDs, but it's a PWM driver. So there are 16 channel and each of them has like 12-bit values you can put in. And whatever requires a PWM, you can run with it. So I think I got it from Adafruit.
It's an Adafruit one, but
Yeah.
does it have enough power?
Well, it can drive the 12
Like
motor.
amperage.
So, I haven't checked that actually, but it's supposed to drive these 12 motors, servo motors I have.
Yeah, stress test would be interesting. I imagine, like, I did the calculation for mine, and I think the peak draw for mine was like 4 amps, which is just about the limit of what the Beagle board can put out. And at a more sort of cruise control level, it would draw something like 2.5 amps. So yeah, it would be interesting to see what your maximum amperage your hat can produce is.
Yeah, it's called PCA 9685.
Yeah, if it's the data sheet that I'm looking at, it looks like it's more like 25 milliamps
per channel, right?
per channel. Yeah. Okay, I'd be right. MA, is that milliamps?
Yeah.
Yeah, that's milliamps. That sounds too weak to run a serious motor, but it's hard to calculate with servos because servo motors kind of don't have an obvious amperage relation. But oh, quick time check. I don't know how much time you allotted for the blockchain discussion, but we are at 10:40, so 55 minutes. So up to you when you want to switch over.
So for the blockchain, I just put some links in there, so we could just Google search and discuss open-ended. So I haven't even like read all the links I put there.
Can you share the page that you put the links in? Is it on the...
Yeah, just a minute. Yeah. So these are the links I could find, some of them. And then there is some research going on here in Finland about distributed robotics with blockchain. So they seem to be distributing the computing loads and doing some sort of coordination with it. So like my idea was basically what are the things we could do or try out on our bots?
I think part of the answer is that we need to have a blockchain module in each rover so that they can share the same blockchain. So we have to fork one of the existing blockchain systems.
And I found this one. So I was basically looking into the hardware part of it, how to run it on different kinds of hardware. So ESP32 has somebody has already ported the Ethereum and they have some wallets on the ESP32. So I found this, I think 2 weeks ago, and there are like Arduino libraries for it. It also runs on the Raspberry Pi.
So there is something that there is no need to fork anything. Okay, it's it can be just using the, I don't know, the Bitcoin source code and run it on a cluster. So the cluster is just a number of computers, and each rover can be a computer. But I have a basic question: is that and maybe this is what we want to discuss: is why do we want to why would we want to do that? What do we expect from that?
So I think we discussed this briefly in the channel. So the two immediate obvious ideas I had was, one, you can run an economy of rovers. So if I want to rent Myers rover camera, I can pay for it. So in a trustless, market-oriented way. So you can do this with rovers that don't trust each other too much. And the other is you can do a level of adversarial coordination where it's like, the example I came up with was on Mars, you might have American and Chinese and Russian rovers, and these three countries are willing to cooperate sometimes in space, but have hostilities. So a blockchain is kind of a good solution for coordination in that mode. But these are like, I don't know, the immediately obvious ideas. So I'm curious if there are more creative ways to use blockchains.
Thank you.
But one of the ways people are talking about in the real world, not in rovers, is putting together large amounts of capital by having guaranteed commitments of small amounts of capital from lots of entities. So a rover is a real-time system. It keeps on changing what it has and what it can do. So a mechanism where it commits in a way that is transparent to the other rovers in the group could be a way for them, for all of these rovers, to coordinate some large activity. But the problem is we can't do proof of work because my rover battery can't handle it. It has to be.
I would think you would submit that to the actual nodes on the whatever blockchain you're using. So this would be more like a client. I would expect wallets to run on the rovers, but not necessarily nodes.
No, we're going to be on Mars. I'm expecting everything to run on the rovers, the nodes, and the wallets.
So you have base stations, you have orbital stations. So there's like ways to distribute that stuff a little bit.
It might sound like a joke, but a Chinese rover, Russian rover, and an American rover go into a cave. Okay, that's how it starts. There's no reason. I mean, it's a decentralized system. Okay, there's no reason to have some central node, except the whole issue of proof of work. So there are blockchains which are not based on proof of work, but on other things, and that's what we should be using. I'm just wondering if anybody has blockchains based on individual pseudo-random numbers, because
Well, I talked briefly during my talk about the blockchain that's based on forwarding mesh networking packets and providing network connectivity for Internet of Things applications.
Mhm.
Isn't this Helium? I
That's
think-
Helium, yeah.
Yeah, Helium is doing this. So yeah, proof of stake is the other big one. It's much lower energy, but I think it's slightly less hardened against trust.
Is it this one?
Yeah, this is Helium.
People power.
So you can sort of use your Wi-Fi router as part of the Helium mining network and make it available for discovery and stuff.
There's also this Filecoin, which provides storage.
Yeah, that's what IPFS uses in the backgrounds. That's a way to, if you generalize that, it can become sort of a resource sharing thing. But I think IPFS, since it's on top of Ethereum, it's proof of work at the moment until Ethereum switches to proof of stake.
yeah, well, we have real physical systems, so can definitely have proof of stake.
And I think blockchain, at least in my mind for the moment, is a placeholder for a type of like decentralized transactional environment. And depending on how much or how little trust you expect, you can sort of like weaken the conditions and like, you don't even need proof of work or proof of stake. You can just have like, I just trust you. If you say you are going to do one, I'm going to trust you. If you don't, then we'll cut down your reliability. So you can have like, I don't know, proof of fate.
Okay.
To me, sorry. I have a pretty different. No, I'm not sure. Maybe I have a different angle. I don't know. Is that space is pretty hostile, okay, to the kind of things we have in mind, okay. And the thing is that even if there is competition between different countries, for example, even if there is competition and some hostility and so on, out there, basically, we are all in the same basket, basically. Okay? And so I see blockchain more as a kind of digital DNA or digital foundation for the artificial life that we are sending there. And a way, perhaps a way to have a decentralized management so that presence can be guaranteed to some extent. So if we take the example of distributed storage like IPFS and stuff like that, what is interesting there is that it's a decentralized way to store data somewhere, okay, and kind of permanently, okay. And so if we put that in space, there is that's what is interesting, that the bits, okay, the knowledge that we have turned into bits is guaranteed to survive as long as there is a minimum number of compute available, okay. And I wonder whether under that angle, okay, that is independent of the countries and so on, but that maps to that. Is there a possibility to create infrastructure so based on blockchain technology so that there is a guarantee that if someone has a stake in space, so when I say someone, it's a country or whatever, whatever happens, this technology allows them to stay there indefinitely. Okay? And there is some kind of symmetry between different countries. There is still competition, okay, but there is kind of symmetry that I provide you the ability to stay on Mars as long as I'm there, and you provide me that same ability. Sorry, I don't know how to phrase that, but I hope something went through.
Venkatesh, you unmute.
I think the way I would frame what you just said is one of the important dimensional axis is degree of cooperation. So from adversarial to cooperative, and that's one parameter. But another parameter just occurred to me, which is in Bitcoin, there's like mining becomes more and more difficult, which is why like it costs more and more power. But in the early days of Bitcoin, it was very cheap, like in terms of like computational power. And one of the reasons it increases is because the incentives are such that when the profits are high, more and more miners will come in. So you have to raise the difficulty so that the block verification time stays the constant or something like that. And that's because it's an open system where with a profit motive, people are going to enter and exit the mining market. And that's why it becomes so energy intensive. Now, in space, you actually have a different problem. There's never going to be like an easy entry point where if you have like like say 50 rovers on Mars and suddenly you have like lots more transactions, it's not going to attract 2 million more mining robots to Mars overnight, right? So I wonder if the fact that the number of nodes is limited means the difficulty level can be capped low enough that it can be done with extremely low compute. So this is probably a mathematical thing to be looked into, but something like if there are no more than 50 rovers, then it should cost no more than like, so many watts to mine so many hashes or something like that. So there's probably a strong correlation between power utilization to run proof of work and the number of nodes that are running. So I think there's more room in this design space than we think, because all the blockchains on Earth are extremely competitive, large-scale open markets where miners come in by the millions.
But what you're basically saying is that we're going back to the Byzantine general problem, because we only have as many rovers as you actually have Byzantine generals.
Yeah, some function of that. Like maybe each rover can be unbundled into like 50 capabilities, and like there's some limit, like even if that varies a lot, right? So maybe all of them are individual nodes or resources or something.
Have you heard about
Yeah.
the folding at home project?
Yeah, the protein folding
Yes,
thing. Yeah.
yeah. So you can volunteer your own computer.
And this was
for
after SETI at home, right? SETI at home was the first example of this type of thing.
Okay, so I didn't know about
Yes.
like SETI at home, but I knew about this. So you can volunteer your computing units, and then right now it's just volunteer based, but you could have some reward based on blockchains to provide. If you do certain amount of computing, then you get rewarded for this. So that is what kind of already happens in Bitcoin, right?
This is centrally coordinated though, like all the nodes that do the protein folding calculations are like distributed, but there's like a central sort of clearinghouse that gives them problems to solve. And SETI at home was the same way. It would give you like radio signals to analyze for aliens. So the decentralized version of this, I think there are examples that have done this in a more decentralized way.
Okay.
Yeah, there's lots of options here, I think. But this is actually what you said earlier, Mayor, I think is interesting, like going back to first principles of Byzantine generals' problems and sort of resolving it from first principles for a rover situation. Like assume so many rovers with certain level of cooperation. What's the sort of, I don't know, bespoke local blockchain for that situation? And that might be an interesting question to look into.
So what numbers do you people feel are reasonable to aim at? How many rovers?
Well, what stops a rover from acting like 100 rovers on a blockchain?
Oh, because we have proof of physical stake. Okay, when you arrive at Mars, you get an ID number, which is digitally signed. Okay, and that's it. And Venkatesh says you can have 50 capabilities, so you have 50 ID numbers. But
So who acts as the coordinating entity to pass out such identifiers? The sort of
like one way could be
centralized nature, right?
The proof of work doesn't have to be like digital compute for rovers.
Yeah, but look at it that way. It's like a social security number. Why do you have only one? The answer is when you were born, they gave you one, and that's it. Yeah, you can probably obtain a few more. Okay, but it's not easy to obtain that initial number. Now,
But if you
wanna-
have someone who's able to hand out the number, why do you need a blockchain? Why can't you just have them do everything else?
I think that's not the bottleneck, Meyer. Like, I don't think there's anything stopping a new rover from joining the network and claiming 50 new addresses or 50 new node numbers by just like doing whatever decentralized protocol to claim them. The bottleneck will come elsewhere. It's like, I'm saying you don't need to do that to solve the problem. The actual problem is you need individual node numbers for things that are likely to be adversarial. And the adversariality of the system is capped because, for example, if two motors want to be independent entities on the network, they're part of the same chassis. And if the rover falls off a cliff, both of them die. So there's a minimum cooperative alignment of their fates. And therefore, it makes logical sense for them to kind of share a node ID and not work at cross purposes. So there's like natural incentives forcing things down, but I don't think you need to artificially force it. Like if some rover comes in and says, I want to be like this huge society of mind, Marvin Minsky AI with like 200 agents inside this one chassis, and it wants to claim 200 separate addresses, and it's willing to pay the computational cost of running like 50 nodes on its compute, let it have it. Like, I don't think it actually matters. It's just a very kind of costly decision for it, let me put it that way.
It matters if you're doing proof of stake, because somebody who has a lot of nodes could possibly take over the validator network.
Yeah, so the Sybil attack problem will be.
All I'm saying is the follows. Because we're talking about physical rovers, we have a way of controlling that regular blockchains don't have. Okay? And this is input. In the end, I want the rovers to be anonymous. Let's say we have these 3 rovers in a cave, and one of them has to take a risk. But it doesn't want its government to know that it said they should take a risk. Okay? So it wants to anonymously vote. And we have to provide that capability. But what I'm saying is, when the rovers try to put the vote results on the blockchain, it's difficult to take over the blockchain because the number of actual nodes is more prescribed than in other blockchains.
I think we're making the same point. I'm just arguing that would happen naturally. Like if you wanted, so what you're describing is like a 51% attack, right? Like a Sybil attack, and a single rover doing that is effectively putting up like 51% worth sock puppet accounts on the rover blockchain. And because all the, like, suppose I need to run 200 agents in order to like control the network with majority 51%. And if each of them takes a certain number of watts to run on the limited compute I have, that's a cost that's naturally imposed. So an indirect and I think more organic way of controlling the security of the network is to link the cost of running a node to the, I don't know, wattage available. So somehow calibrated where we know that it would simply be prohibitively expensive for rover to run like more than say 3 nodes, because running a node requires say 10 watts, and on Mars, you don't have that much, something like that. So
I mean,
I'm looking
that's
for more
proof
organic
of work, isn't it?
Yeah, that's basically proof of work. Adjust the difficulty so that it sort of caps itself at some level.
But my battery doesn't last that long. That's the point.
Yes, and
I
that's
want to
the
have
safety for other
blockchain.
people.
I want to have blockchain, but I don't want to use more than 1% of my CPU for it.
So
the
you would
whole
run
idea,
just one node on your rover. But if I happen to have like a bigger battery or like a nuclear reactor and I can do much more, maybe I run a lot more, right?
No, but I don't want you to get oligarchy, let's call it, power oligarchy. I don't want that.
Yeah. So that's where I think unique domain-specific blockchain design would be kind of interesting to look at, because I think Rhett is right. The moment you go to like some, I don't know, coordinating entity that imposes arbitrary constants in the system, like, you know, a rover can only have 50 addresses or nodes or something, you're like getting away from the blockchain approach to design. Like there's very few like arbitrary constants in blockchain systems. Like block size is one, There's an arbitrary 21 million number in the Bitcoin one in particular. But in general, as far as I can tell, blockchains try not to have too many arbitrary constants because then somebody has to police that constant.
I don't know what the current state of the art is on this, but like when JP Morgan tries to deploy their private blockchain amongst branches or whatever, like they had teams of people working on this problem, but the idea was, oh, it's a private blockchain, so you don't have the same, there's no 51% attack in amongst JP Morgan branches, I guess. So, or I don't know, all the nodes are trusted, right? So it's a different design space is what they were trying to claim.
So this was this is kind of a fad about 4 or 5 years ago when Bitcoin like first was getting popular. Microsoft and other big IT companies were like trying to do like, same thing they did with cloud, like public cloud, private cloud. They thought they could extend the analogy to like public blockchain, private blockchain. And one of my first experiences with I used the Colony. I mentioned this morning. So Colony was a dApp on the Ethereum blockchain, but when they were running the beta, they were running it on a private version of the Ethereum blockchain. So everything at a UX level looked like a blockchain, but it kind of like was meaningless because it was running on a private blockchain where I guess they could like reset the master node or something. I don't get the details, but yeah, even though that's a good way to test the environment, but I think there's like weaker versions of that might actually make sense for production. Like if you trust your neighbors enough, maybe you can actually do something like that to some extent.
Yeah, well, the whole point of a proof of stake is that you have a stake. So I'm saying your existence as a rover is a stake. Okay, you get a coin when you're born, and I don't care what you do with it. It's only used, let's call it, for the validator network. Okay, the validator network is limited, let's call it, to these tokens, but everything else is not limited. Okay, so you can have 20 different entities running on your thing, but if you want to have validation, so the validator nodes have to do it, and the validator nodes are no more than the number of rovers which have landed on Mars, which is not a big number. The only question is it 50, 100, or 10,000?
So do you buy your way in to the blockchain by proving that you own an NFT that is a receipt for your launch, which then limits the number of potential participants?
Well, actually, I would think it'd be much more physical. You get seen and you exist, and that's it. But
you land on
way
Mars.
Works as well.
If you land on Mars, 2 other rovers can sort of spot you on their camera, and then you send out a radio signal saying, I exist, this is my name, and 2 others rovers say, I see you, and therefore you're assigned a node by consensus amongst existing rovers, so you're allowed to join the network. It's like, yeah, I agree with that part.
Yeah,
Physical constraints are very powerful here.
Let's just contrast it with what Rhett said. What Rhett said was, when you launch, you paid $10 zillion for it. You get a token. When you land on Mars, you say, here's my digitally signed token. You can call it an NFT with a picture of the launch and my rover and my CPU ID. Okay, I exist. So I was just thinking it would be by identification, but maybe really NFT of launch until we start manufacturing them on Mars.
Oh,
Oh.
There you go.
We're approaching like have 9:05, so and I have to jump out soon. But if you would like to continue, you could.
No, let's stop the discussion here. And next week, Victor was supposed to present, but Victor is dropping out of the project for foreseeable future. He said he'll be back in like March or April, perhaps.